By automating manual tasks that humans do now, you can boost productivity and gain business resilience. This much is clear. Automation gets complex, though, when conditions at workstations aren't predictable, when there's variance. Standard automation solutions can't deal with this complexity, or when they can, they're highly expensive and rarely robust. MIRAI is an AI-powered robot control system that makes it possible to automate tasks otherwise considered too complex to solve. MIRAI is attached to a robot. Once that robot is equipped with MIRAI, it can look out onto its workspace and react to unpredictable situations. MIRAI is made by Micropsy Industries. We're a software company that provides a ready-to-use AI system for controlling industrial robots. We enable automation where automation wasn't previously viable. Today, I'll explain what MIRAI robots can do, what precisely MIRAI is, and how the system works. We're also going to train our MIRAI-equipped robot to insert this plug into this randomly placed socket. Traditional automation solutions couldn't handle this because the position of the socket isn't predetermined. Moreover, other systems would struggle with the precision needed for this insertion. Among other applications, robots with MIRAI can be used for assembly, end-of-line testing, picking, including transparent objects, screw driving, and more. Thanks to AI, a robot guided by MIRAI can handle variance in position, shape, color, lighting, and background. Compared with standard computer vision systems, MIRAI offers higher robustness, precision, and flexibility thanks to its real-time control. No CAD data is needed. MIRAI can also deal with reflections, specular highlights, and transparency. The MIRAI system is attached to a robot. It augments that robot. In a MIRAI robot setup, you'll need to bring certain components to the table. The first one is a big one, the robot. In our case, we'll be working with a UR5E from Universal Robots. You'll also need a force torque sensor, as well as an end effector, in our case, a gripper. The MIRAI kit consists of both hardware and software. Here, we have a standard 2D camera, a camera lens, a ring light and ring light adapter for that lens, our camera mount, and this tablet. Installed on the tablet is the MIRAI training app. You use the app to train the MIRAI-equipped robot to do what you want it to do. Without training, it can't magically perform the task you have in mind. Let's train the MIRAI-equipped robot to insert this plug into the socket. Our overall aim is to have the robot pick the cable, bring it to the socket, and then insert the plug. Using its native controller, we can program the robot to execute many of the required movements. But we use the MIRAI system to handle the complex sections of the task, actually getting the gripper in the position to grab the plug and then insert the plug. The plug and socket are never in predictable positions. So we need MIRAI to take control of the robot during these sections of the broader task. We'll train it to handle these complex sections. To do this, we record a bunch of episodes. Episodes are video recordings during which you familiarize MIRAI with the action you want it to perform and the variance it may come across. From those accumulated episodes, MIRAI learns how to behave when it encounters variance while executing your desired action. Our aim is to train MIRAI to enable the robot to position itself just above the socket, no matter where it is. You can do this by recording 5 to 10 episodes, each one 30 to 60 seconds in length. Today, in the interest of time, we'll do 2 episodes and focus on the plugging. To start the first episode, we guide the robot to its target position. We want to align the tip of the gripper slightly above the socket. Start recording. Begin with a gentle spiral motion outward from the target position. Visit all the positions in space that the robot may visit during execution. Imagine you're scanning the target from various perspectives. Stop recording. Since our episode went smoothly, we'll save it and use it for training. Let's do another episode. We change the position of the socket. Start recording. It's good practice to keep the target in the camera image when you record episodes. You also want to keep your fingers out of the image. You don't want to show MIRAI anything that wouldn't be there when the system independently performs the action you want. As you train, present to MIRAI all the variants it may come across when it performs your desired action. MIRAI will then learn to see the target from different angles and with different backdrops. Let's stop recording for now and exit the training session. Once you've recorded at least 5 episodes, 30 seconds each, you can send the data to the cloud for training. Soon after that, you can test the results. Alright, so it's been an hour. Let's test out the results of our training session. We can fiddle with the socket. We want to gauge how well MIRAI can handle variance after our training session. As you can see, it does a fine job. The execution is robust. Let's review the broader task. There are 6 sections. In the first, the native controller guides the robot to the plug. MIRAI kicks in for section 2 and finally positions the gripper just millimeters from the plug. MIRAI then hands control back to the native controller. In section 3, again under the guidance of its native controller, the robot picks the plug. In section 4, the native controller guides the robot to the socket. In section 5, MIRAI takes over to finally position the plug in front of the socket. Finally, the native controller tells the robot to insert the plug. That should do it. We've trained our MIRAI-equipped robot to perform a task that would be too complex to automate for traditional solutions. As you can see, MIRAI lets you solve automation problems on your own. No knowledge of AI is required. Moreover, MIRAI-powered robots can be trained and retrained for various tasks. If you'd like to discuss your automation challenges with an expert, get in touch. Thanks for your time.